Session 8.2 Solving linear equations in one variable. Linear equation in one variable. A linear equation in one variable is an equation that can be put into the form mx plus b. M and b are constant, and m cannot be equal to 0. Solution: satisfy solution set and solve for an equation in one variable. A number is a solution of an equation in one variable if the equation becomes a true statement when the number is substituted for the variable. Example: consider the linear equation x plus 1 equal to 6. So this is going to be mx plus b equal to something. Okay, so this is going to be the constant. And we know this is the linear equation with one variable. And now we're going to substitute x equal to 5 into this linear equation. So plug in x equal to 5 here. And then 5 plus 1, we're going to get the 6. 6 equal to 6. So this is going to be a true statement. So this is what the definition here says. A number is a solution of the equation if the equation becomes a true statement when the number is substituted. So right now, I substitute x equal to 5 into this linear equation, and I got the true statement. So this means 5 satisfies the equation, and I know 5 is a solution of the equation. And for this example, we only have one solution, x equal to 5 for this linear equation. The set of all solutions of the equation is called the solution set of the equation. We solve the equation by finding each solution set. The solution set of the equation, it just means like 5 is the solution of this linear equation, and the way we solve this equation, find out x equal to 5, we call this a solved equation. Example: identifying solutions of an equation. Is 3 a solution of the equation? I have the linear equation here, and I want to know x equal to 3 is a solution of this equation. So what we're gonna do, we're gonna plug in x equal to 3 here. So we're gonna plug in x equal to 3 here, x equal to 3 here. Every time when you plug it in, it's better you guys put the parenthesis. Okay, on the left hand side, we're gonna take care of the one with the parenthesis. So 3 minus 1, we're gonna get the 2. Okay, 2 times 5 here. And on the right hand side, we're gonna do the multiplication first. So 3 times 2, that's equal to 6. Now 5 times 2, that'll be equal to 10. And 10 plus 6, that'll be equal to 16. Is this a true statement or false statement? This is the false statement, right? So we know that 3 is not a solution of this equation. Okay, try another example. Is 5 a solution of the equation? I want you guys try to do it by yourself. Plug it in to see if you're gonna get the true statement or false statement. Okay, plug in x equal to 5. Take care of the parenthesis here. This is going to be 4 times 5. And this is going to be 10 plus 10. Now, 5 times 4, that'll be 20. 10 times 10, that'll be also equal to 20. And this is going to be a true statement. So 5 is a solution of this equation. Make sure after you guys plug it in, don't stop at here. Answer the question, okay? 5 is a solution of this linear equation. Addition property. If a and b are expressions and c is a number, then the equation a equal to b. So I have this equation A equal to B. I could add up the C for both sides. Okay, I could add C on the left hand side. I could add the C on the right hand side. So I still satisfy this equation. And I know A plus C will be equal to B plus C. And we call this as the addition property. We'll be applied the addition property when we solve the equation. Look at this example. Solving an equation by adding a number to both sides. So I have an x minus 2 equal to 3. If we want to isolate the x here, we need to get out of my 2 in here. So what we can do to get out of the negative 2 here, we're gonna do the opposite. When you have a minus 2, we're gonna add 2 for both sides. Okay, I want to isolate the x, so I want to get out the negative 2. In order to cancel out this guy, we're going to do the opposite. When you have a negative, you're going to get the positive. So plus 2. When you plus 2 on your left hand side, you're going to do the same thing on the right hand side here. So right now, these 2 cancel out. You only have the x in here. So x is going to be equal to 5. After you guys solve the equation, it's a good idea that you're gonna plug in back x equal to 5 into your linear equation here. Okay, check your work. So I have an x minus 2 equal to 3, and then we're gonna plug in x equal to 5 in here. 5 minus 2, that's gonna be equal to 3. And I got the true statement. So I know 5 is the solution of this linear equation. On the exam, you don't have to show me the checking this part here, but I highly recommend you guys do it on the scratch paper. After you solve your equation, check your work. Okay, multiplication property. If A and B are expressions and C is a non-zero number, then the equation, when we have the equation A equal to B, if I multiply the C on my left hand side, I need to multiply the C on my right hand side. So AC and BC are equivalent, so they are equal to each other, and we call this as a multiplication property. Let's try the example. Solving an equation by multiplying both sides by a number. So I want to solve this equation, and I want to isolate my x here. So we're gonna multiply both sides by the reciprocal of the coefficient of x. Reciprocal of this guy means you want to fit this number. The reciprocal of 4 over 5, that will be equal to 5 over 4. Okay, so I'm gonna multiply the reciprocal for both sides here. So you could see I could simplify it. Cancel out the 5, cancel out the 4. I only left with the 1 in here. Okay, that will be 1x on your left hand side. On the right hand side, simplify it. X divided by 4, you're gonna get the 2. 2 times 5, you're gonna get the 10. And remember, if you have the variable and 1 is the coefficient of the variable, you could just ignore it. You could rewrite it to x equal to 10. So the solution is going to be equal to 10. I want you guys try to do the checking by yourself. Plug in back x equal to 10 to the original equation to see if you're going to get the true statement. Okay, another example. Solve this equation, negative 12 equal to negative 3t. And this time you're gonna see my variables is gonna be on my right hand side, okay? But it doesn't really matter because this is an equation. Left hand side is gonna be equal to right hand side. And then we want to isolate my variable t in here. So means I want to get out of this guy. And you could see the operation. This is -3 times t. When we have a multiplication, we want to do the division. So we're going to divide it by both sides by -3. Okay, divided by -3 for both sides. And here you could see I cancel out. I left with the t. And -12 divided by -3, which is going to be equal to 4. So the solution is going to be equal to 4. Again, check your word, plug back to here. 4 times -3, that will be equal to -12. Okay, another example. Solve -w equal to 5. Okay, I could see I want to isolate my w here, and then I have the -1 in front of it. So what can we do? We could divide by -1 for both sides. Okay, you do have the imaginary 1 in here. So divided by -1 for both sides. Negative, negative, you're going to get positive. So this is going to be -5. Or what you can do, you could multiply by -1 for both sides. So I have this guy here. Now I'm gonna multiply -1 for both sides. You're gonna see negative, negative, you become positive. And this is gonna be equal to -5. You're gonna get the same answer. Okay, it doesn't matter which method you pick. You could divide it by -1, or you could multiply by -1 for both sides. So you know the solution is gonna be equal to -5. Okay, another example. Solve 2x over 3 equal to 5 over 6. And again, when you see this, when you see the fractions, you're gonna think about it. You will be multiply both sides by the reciprocal of this number. And the reciprocal of 2 over 3, which is gonna be 3 over 2. For your x, 2x over 3, I could rewrite it to 2 over 3 times the x. Now, I'm gonna multiply the reciprocal for both sides here. After I multiply the reciprocal, I should be able to simplify it. Okay, simplify 3 and 3, 2 and 2. So I only have a 1x in here. This guy, simplify before you multiply. So simplify the 3 and 6. This is going to be 1, this is going to be 2, so that's a 5 over 4. And then when I have the 1 here, I could just ignore it, so x equal to 5 over 4. Okay, I want you guys check your work. Plug in x equal to 5 over 4 into the original equation. So the x here, I'm gonna put it like here. So for the x, I'm gonna rewrite it 2 over 3 times x. And my x, that will be equal to 5 over 4. Okay, simplify it. 2 and 4, you could simplify. This is going to be 2, right? So 5 over 6 equal to 5 over 6. So I got the true statement. So I know the solution will be x equal to 5 over 4. Okay, try this example. Okay, I want to isolate the variable of 2x. So first step, I want to get out of the -3 here. So what we're going to do, we're going to apply the addition property. We're going to add 3 for both sides here. So -3 plus 3, you cancel out, you only have a 2x. Then this is going to be 5 plus 3 equal to 8. Okay, how can I isolate the variable of x in here? you're going to divide it by 2 for both sides. So x is going to be equal to 4. Okay, check your work. Plug in back to the original equation. X equal to 4. So this is going to be 4 times 2 equal to 8. 8 minus 3, that will be equal to 5. And I got the true statement again. So I know I got the correct answer. The solution is x equal to 4. Okay, one more. Combining 9 terms to help solve an equation. So you could see this is my linear equation. The 9 terms will be the 4x and 7x. And these two, the constants, 2 and 17, this is also the 9 terms. So first step, I want to combine the 9 terms on your left-hand side here. So 4x minus 7x, that will be negative 3x plus 2. And then I want to isolate the 3x, the negative 3x here, so I want to get out of my 2. So what you're going to do to get out of your 2 here? You're going to subtract 2 for both sides. So now you have negative 3x equal to 15. Now divided by negative 3 for both sides, you're going to get x equal to negative 5. Okay, check your work. Plug in back to the original equation. So plug in x equal to negative 5. So this is going to be negative 20 plus 35. Okay, negative 20 plus 35, that will be 15. 15 plus 2, 17. So I got the true statement, means the solution is x equal to negative 5. Okay, combining 9 terms to help solve an equation. So try these questions by yourself. Okay, do I have any 9 terms on your left-hand side? No, right? Any 9 terms on the right-hand side? No. So now I know negative x and 2x, that will be my 9 terms. So I want to combine these two guys together. So what can we do first? I don't want any variable has a negative number, so I want to get out of this guy first. So I'm gonna plus x for both sides. So negative x plus x, you're gonna cancel out. So you only have a 7 on your left-hand side. Here, 2x plus x, you're gonna get 3x. Okay, now I want to isolate the variable of 3x here. So I'm gonna get out of the negative 2. So I'm gonna plus 2 for both sides. So you're gonna get 9 equal to 3x. And then you're gonna divide it by 3 for both sides. So 3 equal to x. So x equal to 3. Okay, check your work. Plug in back to the original equation. Negative 3 plus 7, that will be equal to 4. And this is going to be 3 times 2 equal to 6. 6 minus 2 here. So 4 equal to 4. And this is going to be the true statement. So the solution is 3. Okay, example, solving a percentage problem. In a survey, 36% of adults say police departments do a poor job of holding officers accountable. if the number of adults in the survey who say this is 540, what is the total number of adults surveyed? So pay attention for this one. The number of adults in the survey who say this is 540. So first, we are looking for the total number of adult surveys. So let N be the total number of adult survey. Okay, N will be the total number of adult survey. And we have 36% of the adult survey is equal to 540. So I could break it down like this. 36% of adult survey. And we already let N will be the total number of adult survey. So I have 36% of means multiply. Multiply by the N here. And equal 540. So I have this guy here. Set up the equation first, and then we want to solve the equation. We want to find out what is your N here. So 0.36N equal to 540. So we want to isolate the variable of N. We're going to divide it by 0.36 for both sides. Okay, take care of the division. That will be equal to 1,500. And then answer the question. So the total of 150 adults were surveyed. Okay. Using graphing to solve an equation in one variable. To use graphing to solve an equation A equal to B in one variable x, where A and B are expressions. So this time we want to use the graphing to solve an equation in one variable. Graph the equation y equal to A and y equal to B in the same coordinate system. So right now I have two equations here, y equal to A and y equal to B. For example, if the original equation is 5x minus 9 equal to 3x plus 7. So this is just similar to the previous example. We want to solve this equation. We want to find out what is the x. But this time, we'll be using the graphing to solve this equation. So what can we do? We're going to separate into two equations here. I'm going to let y equal to 5x minus 9. And another equation, y equal to 3x plus 7. Okay, so this is means like y equal to A and y equal to B. And y equal to mx plus b. This is the linear equation with two variables. So I want to graph these two linear equations in the same coordinate system. And then find all the intersection points. Number 3, the x-coordinates of those intersection points are the solutions of the equation A equal to B. So after you find the intersection, you should get coordinate. And the x-coordinate will be the solution of this original equation. Okay, let's try to do the example. The graph of y equal to 3 over 2x plus 1. So I have the linear equation in here. I have a two horizontal equation, y equal to 4 and y equal to negative 5. Use this graph to solve the given equation. Okay, so look at this graph here and I want you guys to find out the solution of this equation. So first, I have a 3 over 2x plus 1. Okay, so this is y equal to 3 over 2x plus 1, just like this equation. Second equation, y equal to 4. And then I'm going to draw these two linear equations into the coordinate system, which is going to be these two lines, right? The blue one and also the red one. Okay, find out what is the intersection. That will be the 2 and 4, right? The intersection is going to be 2 and 4. And what is the x-coordinate? X-coordinate will be equal to 2. So the solutions of this equation will be equal to 2. You could double check your work. Plug in x equal to 2 into original equation. Okay, so simplify it. 3 plus 1, that will be equal to 4. And this is going to be the true statement. So I know x equal to 2 will be the solution of this linear equation. Okay, next one. Again, I have these two equations. I have a y equal to 3 over 2x plus 1, which is going to be the blue line here. Another one, y equal to negative 5, which is going to be my green one here. So what is the intersection point? It will be this one, right? Negative 4 and negative 5. What is the x-coordinate? That will be negative 4, right? So negative 4 will be the solution of this equation. Again, check your work. Plug in the negative 4 into original equation. So simplify it. This is going to be negative 2 times 3, which is going to be negative 6 plus 1. Negative 6 plus 1, that will be equal to negative 5. So this is the true statement. And I know the solution is negative 4. Okay, last example. Solving an equation in one variable by using a table. Some solutions of y equal to 3x minus 5 are shown in the table. Use the table to solve the equation 1 equal to 3x minus 5. So I want to solve this equation. So what you're going to do? You're going to separate into two equations. This guy, that will be y equal to 1. This one, that will be y equal to 3x minus 5. So I have the coordinate in the table here. When y equal to 1, look at here, y equal to 1. That will be this guy. What is the coordinate of x? That will be 2, right? 2 and 1 here. So now, we're going to plug in this coordinate into this equation. Y equal to 1 and x equal to 3. That will be 3 times 2, that will be 6. 6 minus 5, that will be equal to 1. Okay, so that means the coordinate of x equal to 2 will be the solution of this equation. That's it for the session 8.2.